Ladies and gentlemen, and builders of all ages. All right, what you see here in poor resolution and bad sound because I talk too loud and I overload the computer or the camera, and then sometimes I'm overloading the speed of the computer and the voice gets a little wonky. But let's suffice. Let's look at this box here. It looks like a power supply. It's 50 years old. I built it when I worked in Radio Shack part-time. Now, it's built with mostly Radio Shack parts. It's built in a certain size Radio Shack case. It gives you 1 amp at 25 volts, and it's variable, and you can adjust the current. All right, let me get in between the light here. All right, lid can come off. I'm all ready because, well, why didn't you show us what was inside? This is what I got at Radio Shack. People that would come in, they heard about this power supply. They come from many miles away just to see it. So anyway, let me show you. It does still come on. You can adjust the voltage, and this is the current adjust. This is voltage for the meter, and this would be your current when you're measuring current. All right, minus, plus, indicator light. All right, now let me unplug it so I don't shock myself. So it's 50 years old, and at the time I was working in Radio Shack, and somebody asked me what I was working on, and I said I'm working on a power supply, and it shuts down if you overload it. No, it's got all the bells and whistles of a larger HP, but I didn't need all that. So, I built it just for my purposes. And then other people, well, where did you get the schematic from? It just became a nightmare. I showed it to one guy. I put it behind the counter on the shelf, and somebody spotted it. He had several friends that came in. One guy got on the CB radio, made more people come in. See, a lot of people wanted to build this type of supply, but had no use for it. Doesn't matter. When you really understand people, they want something just for bragging rights. Now, the original article required a Darlington transistor and a large heatsink out the back here. Now, if you notice, I got the power off. There's 3. I think they're 2S. No. What transistors are? Not tips. 2N 250. Yeah, that sounds about right. And notice, there's no insulation under them. There is heat transfer. You can see the heat transfer, hopefully, if I have enough resolution. Here's a fuse. And why I went with that was by using 3 transistors, I would need that big heatsink. Each one of these can get hot to a certain amount. I figured it all out with the square footage or the square inches of aluminum, the chassis as a heatsink. Now, these are in parallel, but I don't know if you can see down in there. Now, down in there, there's a little resistor, less than an ohm, off of each emitter of the transistors, so they can be paralleled without one running away in temperature and blowing out. Now, these are basically the output of a Darlington circuit, and I couldn't get the Darlington for the project. The guy said he didn't have any more, whatever. So I went and made my own Darlington because I just happened to have gone to an electronic course, and I remember with a Darlington. Well, here's the driver transistor here, this red one. This drives those 3 output transistors. These 2 resistors set the current monitoring, and as part of the setting the current for the unit. And then, of course, you have your transformer here. You have your full wave bridge here, capacitor here, and then another module board over here. And this is where the op amp is. It's a 741C, and it's in a socket. And this is a Zener diode with another Zener diode and thing across it. So you got a Zener at 6 volts and then you have another one across that. So that gives you your regulation, the sensor for the regulation. The other side of the op amp goes over and it goes to the positive. So as you're drawing current, it's watching that you don't draw too much. As soon as you draw too much, the op amp and that shuts down the output transistors. Now, so people that were starting to build it, they all wanted the schematic. I think I almost learned that in RCA with the guys that were all going to build the grid dip meter, and they all had a paper bag with the diagram with 3 parts, and they were all in my drawers. And I finally asked her, "What is this?" Oh, they're going to build grid dip meters, and I'm like, "No, they're not." I'm looking at the date on this thing. It's like 12 years old. So I went to some of the guys, and they actually would say, "Oh, I'm going to get to that." I'm like, "No, you're not. You're going to come get the paper bag today, or I'm going to throw the parts out, or I'm going to put the parts back." Nobody showed up. Other people had been laid off. They didn't take it with them. So I dumped the parts out from the paper bags, and I realized they were parts that were in our area. Put them back in their spot. That's as far as that got. See, I should have learned at that moment how much bullshit artists are. Now, after I have this built and people can actually look at it and they go, "Well, why didn't you do this?" Why, yeah, they're great. They're great. Why didn't you do this? How come you didn't do that? How come you don't have one? Okay, that's what I actually said to them. "Well, where's yours?" "Well, yeah, you're building the greatest one in your brain." Now let's look at this. This is 50 years old. Used it over 1,000 times more, and this can stay on for 24 hours. It's continuous at 1 amp, 25 volts. That would be 25 watts. And this is a pretty big transformer. I think it was like $9 or whatever. And we had this cheap guy, Joe. And Joe kept insisting he was going to use one of the transformers off his truck. He had a van, and he repaired furnaces. And he kept asking me, "Well, what's volt amps mean?" I said, "I don't know." I said, "I don't use that. We use amps and voltage, but not volt amps." I think it's you multiply the amps times the voltage, and that's what the transformer is called. But you have to know more than just volt amps. So if you got you got this giant box of transformers from furnaces that says 5 volt amps or whatever that. You got to measure. You got to measure the voltage of the transformer, and then you got to kind of work backwards if you don't know what the transformers are. And he kept bugging me. And then he finally said to me, "I need you to fix mine." Now, it went from like, "Well, how do you put a square hole in the front?" So you see the meter? See, it's in a square. Oh, and those numbers on the meter, they're rub-on numbers. You go to a DuPont graphics place. And this is a 1 milliamp meter. And then it says V/A. I put that in there. Custom made the meter for this. And that was another article in one of the magazines. And I read it, absorbed it, made it happen. Now, how you cut a round hole that big? You get your compass in there, and you have tape. You tape everything up so it don't get scratched. And then you find your center of where you want the meter to go. You swing your compass, and I don't mean the compass to find the North Pole, and it makes circles. You put that in, you screw around, and then you drill a hole, and then you make the hole a little bit bigger with one of these, and this is called a reamer. And this is how you make the bigger holes for the controls. See, when you're working in a metal box like this, you don't want to use really big drills. So you drill a small hole, get up to a 1/4 inch, stick this in, and work your way in as you turn, and the pieces of metal come off. Very easy to cut this project box. It's a Radio Shack. And then you work your way, make the hole the right size. And you might want to test to make sure the hole is staying centered. You might want to touch it up with a file. But to do the meter, same thing. You drill a hole, and then you put the reamer in there. And then after you get the reamer in there, and you get the hole big enough, in comes these. And these are nibbling tools. And you come in, you have your paper or tape back here with the circle on it, and then you come in through the front and you nibble You nibble away the metal. That's how you make a large round hole in a metal box. You have to want to do it. But what I didn't learn was how much bullshit there was. Now, one guy that built it, his name was Ernie, and I think I told this story once before. Ernie kept taking I would build it for Ernie, he'd take it apart. And he kept trying to prove to his wife he could build this. And he kept screwing it up, giving it back to me, screwing it up, giving it. Finally, she called me up and said, she didn't know, back then they really didn't say Alzheimer's. She says, Ernie's not well. But one of the kids that hung in the Radio Shack, he could actually do Ernie's voice. And I just said to him one day, I said, the guy calls me up on the phone and he cries that he can't get it to work. And he used to be real smart in electronics. But a lot of guys are smart. They can do the company work, but to actually build and lay stuff out. Now, when I was building this, I got a lot of backlash from people. Oh, how come you're not using a circuit board? Well, you can use real estate in this that you're not going to have with a circuit board. All right, you can hang stuff off of spacers, and there's terminals under here. The terminals are facing down, but normally the terminals would face up. But I sat there and I looked at this box, and in my mind I laid out all these parts so they'd all fit. All the things I wanted out of this power supply are here, and it's 50 years old now. It has served me well. I just used it the other day. But as I'm using it, I'm thinking, let me do another video on this thing. It is one of my better accomplishments because I looked at that box and I realized I wanted a custom meter. So I went looking. And these guys were following this and they're like, well, what do you care if there's voltage markings on the meter? See, you don't need any calibration on a power supply that's never going to be used. See, what they do is they don't they baffle people with bullshit rather than let's see, you can, in other words, you can't dazzle them with brilliance, so you baffle them with bullshit. And that's what a lot of people are. They learn a bunch of buzzwords and they don't really understand what they're talking about. And my father, God bless his heart, a lot of times I'd be doing something, he would be trying to pick the buzzwords up so he could go and brag to his guys at work. And the guys at work were like, they would call me up and they're talking to me. I said, look, this thing's way up ahead of what you want. And they're like, well, could you build me one? Could you build this stuff? I had people coming to me with ideas for inventions that had already been built, and they wanted me to make it. The one really bad one was a guy he played the bagpipes, and he just wanted the flute part, or the whatever you call that thing, he just wanted it to play the scale, or whatever scale bagpipe uses. When he pressed his fingers, so rather than build this thing, I took the phone message. Someone told me to call him. I called. I went looking on the internet. I found the thing. It's $38. So I called him back. I said, dude, they make the thing for $38 is a lot of money. And he was going to pay me. I said, exactly what were you going to pay me to design and build this thing for you? Well, I thought you would do it for free. That's not what you said. You said you would take care of me. That's another bullshit statement. But this unit drew in some of the biggest bullshit artists ever. Now, this guy, Joe, who worked for the fixing furnaces, he finally gives me the unit, and he says, make it work. I'll take care of you, type of thing. So I went through it, and he had a lot of wiring wrong, and the transistors were wrong. And I went and bought some transistors, and a Zener diode, and a couple other resistors. And, I have to drive around in my car and locate these things because Radio Shack had certain values on the wall, but not the values we needed. And I put the thing together, and he comes in, and he's testing it out. He's really making sure it works good. And then I said, you owe me $6. We'll make it $6. $6 for what? I said, well, those 3 transistors, they have to match. You have to have them match. You can't use Radio Shack ones. You'll notice one, even though it's got an equalization resistor, you'll notice one transistor is getting hotter than another. And I went through this in RCA when I did power supplies for the Pneumatron tubes. So anyway, he wouldn't give me the $6. So I took the power supply and I cut out all the stuff that I put in it, and I made sure the leads were too short to reuse. And then I scooped them off the counter and threw them in the garbage. And he stormed out. And my friend, or the guy that working with me, he looked at him. He goes, "That was really funny." He says, "You were willing to throw money away." I said, "Yeah, I'd rather throw $6 away than let him walk out of there after he said, 'I'll take care, or I'll pay you whatever it costs.'" Yeah. So that what I did was, after that, I would ask people for half the amount of the repair, and they wouldn't pay it. It's like when I was doing R71As. I need $60. What do you need 60 for? Well, shipping both ways, 30 something dollars. So I need $60. Well, I ain't paying that much for shipping. Well, I'm not going to fix your radio for you. Well, we're not going to go in that stupid circle. That's a circle for morons. I can't believe how people are. Well, I think the $30 or the 60 shipping should go towards the repair. Well, you're going to come pick it up? Well, how am I going to come pick it up if I live in Kansas? Yeah. So you go in a circle, you do the dance with the stupid people. And there are a lot of stupid people out there. But I just wanted to show you, this is 50 years old. It still works. I still use it. And I could see I got some hum modulation capacitors in here that I added probably 3 years ago when I learned about hum modulation. Pretty cool stuff. I think that's it. All right, that's it.